Hi. In this video, we are going to deal with transposes and inverses of some matrix A. Okay, so let's just start with what is a transpose of A. Transpose of A, we get transpose of A when rows and columns of a matrix A are interchanged. So, first, how will we denote transpose? Transpose of A we will denote as A prime, although please remember you can see this in some books that AT is also an acceptable answer. Look, what does it mean? Idea of transposing matrix A is very easy. But imagine that you've got some matrix 1, 3, 1, negative 1, 4, 5, 2, 1, 6. Okay. In order to obtain transpose of A, we need to what we need to do is to interchange rows and columns. So look, basically, what needs to happen is that each row must become a column, or what will have the same effect, each column must become a row. So look, now instead of first row, 1, negative 1, 2, we will have first column, 1, negative 1, 2. Then the second column will be 2, 4, 1. And the last one, 1, 5, 6. And as you see, this is a very, very easy thing to do. Let's just do 2 more examples, and we can move to inverses, which are a little bit more problematic subject. Okay, so what if our matrix B is 3, 8, negative 9, 1, 0, 4. Okay, so look here, when we transpose matrix B now, first row must become the first column. So look, here we get a very simple situation. That was 3 by 3, we got 3 by 3. Now, if B is 2 by 3, then transpose must be 3 by 2. So we are getting 3, 8, negative 9, 1, 0, 4. Okay, still not very complicated, but let's see what happens if I'm going to say matrix D. And matrix D is 1, 0, 4, 0, 3, 7, 4, 7, 2. Okay, now I'm gonna transpose this matrix. What am I getting? 1, 0, 4, 0, 3, 7, 4, 7, 2. But this is simply matrix D. So what is so special about matrix D that when we transpose it, we are obtaining exactly the same matrix? Well, this matrix D is an example of a symmetric matrix. What is a symmetric matrix? Look, symmetric matrix, to find a matrix that is symmetric, you just need to first go to look at principal diagonal. Well, first, obviously, for matrix to be symmetric, it needs to be a square matrix, right? It must have the same number of rows and columns. But then, look, if you look at these 2 triangles that you see over here, those elements are mirror reflections with respect to principal diagonal. And as you So you see here diagonal and here diagonal, they look the same after transposition. But look, because here we have the symmetry of elements, when we transpose this matrix, we will obtain exactly the same matrix. Okay, and I think that is enough. Let's now review some properties of transposes. We will not be proving them, but we will illustrate all of them using examples. Okay, so we've got three main properties of transposes. Okay, and they work like that. First one, very simple. Transpose of a transpose of A is simply A. Well, I don't think that should come, I'm going to write it here because here we will do examples. Okay, so we've got that. If I transpose matrix A and then I'm going to transpose the transpose matrix, I'm going to get A. And then the second property is that A plus B transpose is actually the same as A transpose plus B transpose. Oh, you will get why it needs to be like that with this property. Once we do an example, it becomes pretty self-explanatory. Then finally, we've got AB transpose is the same as B transpose times A transpose. Okay, here let me explain why do we need to change the sides to make it for this to make sense. Look, if this matrix is n by n and this matrix is n by q, what will happen if I'm going to transpose it? A transpose will be n by m, while B transpose is going to be q by n, right? So look, only if I reverse their order, I will be able to multiply those two matrices. But okay, let's first do an example, and we'll see how it goes. Okay, so let's just say that we've got matrix A. The matrix A is 4, 1, 9, 0, and matrix B is 2, 0, 7, 1. Okay, so now first let me transpose A. This will be 4, 1, 9, 0. And now if I'm going to transpose A, the transpose is transpose away, I'm going to get 4, 9, 1, 0. So we see that this property works pretty well. Okay, so now let's check property number 2. First, let's calculate A plus B. A plus B is 6, 1, 16, this is 0, yeah, 0, and so we get 1 over here. Now, transpose of A plus B then must be 6, 1, 6, 1, 16, 1. Then, what should I already have inverted matrix A, transpose matrix A, I need to transpose matrix B. So I'm getting out of it that this is going to be 2, 0, 7, 1. Now, if I'm going to add them up, so A So at least this property works very well. Okay, so now the last property. First, I need to multiply A by B. Okay, so I've got 4 times 2 is 6 plus 1 times 7, 13. Then I've got a 4 times 0, 0 times 1, 1. Then I've got 18 plus 0, 18. And 0, 0, 0. Okay, so AB transpose is 13, 1, 18, 0. Okay, and now I need to multiply transpose matrix B by transpose matrix A. Okay, so this is going to be problematic. Okay, 2 times 4 is 8. 2 times 4 is 8 plus 7. Okay, I'm sorry, I need to put them here. 0, 1, 4, 9, 1, 0. Okay, and what we've got? We've got 2 times 4, which is 8, plus 7 times 1, which is 15. Okay, which seemed that I made a mistake somewhere. And let me just find out where did I make this mistake when I was multiplying. 4, 8 plus 7, of course, 8 plus 7 is 15. I'm sorry very much. Too many videos for one day. Okay, so we've got 15, now we've got 0, 1. Then I've got 18, 0, 18, and 0 and 0. So again, we can clearly see that the method is working. Okay, this time, let's finish. This is all about transposes, and in the next video, we're gonna tackle the problem of inverses.